Okay, hello and welcome everyone. This is Peter Robinson here and it's the Ethereum Engineering Group Meetup. Today I've got Vanessa who is going to tell us all about MEV attacks in Eth2. So Vanessa, could you introduce yourself, please?
Yes. So hi everyone, my name is Vanessa Bridge. I'm a researcher and software engineer at Consensus. I've been working here roughly for 5 years, and I've worked in a number of different research topics, including protocol security, simulation, more recently working in the protocols related to Eth2, so the second layer of Ethereum. And currently I'm looking at MEV, which we'll go into. My background is in engineering and I am in Canada. And I think that's enough about me.
Oh, I thought you said you didn't even say Canada. Hey.
Hey.
Sorry. Anyway, please. All right. Anyway, please share your slides.
Yeah. So I'll share them now. You can see them.
Yes, we can.
Okay, all good. So what is MEV? Let's start with this. Let's just give a little bit of context. MEV was something that was coined back in 2018, 2019, when these researchers came together and they were looking at the protocol, trying to understand if actions that were taken on the transactional level of the blockchain could affect the inner parts of the protocol. And what they found out was actually that indeed it could. So they released this paper called the Flashpoints 2.0, which makes reference to like Flashpoints 1, which is related to high frequency trading in Wall Street from a few years back. And what they determined was that they could get this value or revenue by implementing certain strategies. So they called it miner extractable value. The idea being that the miners in a blockchain could strategize and reorder transactions to get the most revenue. And so this would go against users and also against the normal ordering of the protocol. And so what it was called was miner extractable value, for short MEV. And it's this notion that by interacting with the smart contracts, you can optimize for the order of the transaction fees and even do some crazier things. And that creates this price gas auction. So basically, let's say you have transactions for a smart contract, you're trying to buy some tokens, maybe get some arbitrage opportunity. You're gonna be having this auction that is public between different participants. So this is what's called the price gas auction. And then that auction results in higher fees and so more rewards for the miners. And this can cause some consensus vulnerabilities, as we'll see. And so what happened was that after the publication of this paper, more than one strategy was found. So bots were initially just competing against each other doing this price gas auction, but then everybody that found a way to exploit it, not necessarily the miners, were starting to extract this value. So now it's more or less called Maximal extractable value, but still using the MEV acronym. And so the idea is that you can search different opportunities in the meme pool, for instance, like price discrepancies between decentralized exchanges and other activities that we'll see as well. So just to give some context, like arbitrage opportunities is something that is usually called in finance when you have a risk-free profit opportunity. So as I mentioned, if you see two decentralized exchanges listing a token with different prices, you can buy low in one and sell it higher in the other one, and thus creating this sort of like risk-free profit because you know you're certain to get this. And so this is just an example to illustrate it. Let's say that we have this token, the free token, and it's listed at 1.094. And then in another exchange is listed at 1.666. So if you have enough ETH, you can buy this token. change it into the free token coin, and then sell it to another one, to another exchange, and then create some profit for yourself. So in this example, you go from 0.14 ETH roughly to 0.93, which is a substantial reward. And there's been many cases of this. So this is just a real transaction listed where someone identified that the price discrepancies between SushiSwap, 0x, and Uniswap could result in a large revenue. So because of the nature of the Ethereum transactions, you can have like atomic transactions within one single transfer and create all these lists of transfers to ensure your profit. A different type of opportunity is called a liquidation. So basically in the blockchain, we've implemented something similar to what you can do in traditional finance. So you can have a collateral that is saved in a smart contract, and then you're gonna borrow against that. But the difference is that in the blockchain, anybody can liquidate your position. So even though you created this, even though you borrow this and you put your own collateral, anybody else can come when there's changes in the price of the assets. You need to either add more to the collateral or terminate your transaction. So anybody can do that actually. So if I see that there's assets where I could benefit by paying what has been borrowed and then getting the collateral, which is worth more, I can look at that and create a transaction to extract it. And so this is an example from these types of transactions where someone is basically covering the DAI that someone else borrowed and getting the link token and increasing their revenue or reward from these transactions. So a lot of transactions in order to do all the exchanges, but basically it's different ways that they can capture more revenue. But here's where it gets more complicated. Because Ethereum is a peer-to-peer protocol, whenever you identify any of these opportunities, you have to broadcast it into the network before it gets mined. So in theory, everybody else that sees your transaction can potentially recreate that transaction and try to get it included in the block before you. So this is where the price gas auctions games originate. Basically, if you identify an opportunity to make profit and you broadcast it, someone else that is willing to pay a higher transaction fee in order to do the same transaction and collect the rewards is able to. And essentially after the Flashboard guys, Flashboards released their paper, everybody started building their tokens and these auctions started to happen. And so what does that create? Different types of attacks. So the first attack that I just described, when someone sees your transaction and tries to send a transaction that is recreating the same profit opportunities, but faster than you, it's called front running. So like basically it's trying to exploit the asymmetries in information, right? So usually it's not something that happens in finance because information is not that easily accessible in terms of who's trying to do what trades. You can't see other people's, in theory. There's dark pools and other stuff that we're not talking about, but in finance, this shouldn't be happening. But in Ethereum, because of the public transactions, everybody has access to this information. And so a lot of front running can happen and was actually happening in the blockchain. So this is from the paper that I mentioned. This is two accounts that are outbidding each other in the span that one block gets generated. So usually we say that the average time that a block gets added to the blockchain is 14 seconds. So here we see that like around the 2-second time, these two addresses start outbidding each other. When you see this little star is when the transaction that they sent actually got included, but they keep outbidding each other. So that's also a lot of wasting of resources because they're going to have to pay at least the gas for each of the transactions that they're sending. Similarly, there's another type of attack that's called back running, which is less frowned upon just because it's kind of strategizing when someone sends a big buy order or sell order, you can send a transaction that it's immediately after, so that you can benefit from the price change that you know will happen because of the large amount that is being bought or sold. So basically that allows you to generate some profit, but it's not affecting the person that was sending the transaction as much as front running, where you're actually kind of stealing the arbitrage opportunity they might have identified. And then we get into more complex attacks. So like the sandwich attack, where, as I mentioned before, if you see that someone's sending like a large buy or sell order, you can do something after, but a sandwich attack is kind of like using that information and buying the order before so that it increases the price, profiting from that, and then profiting from the fact that you know it's going to be sold immediately after. So you're kind of like putting the two transactions, one on top of the other that's being sent. And so that's a way that you can also create profit for yourself. And this is where it starts getting even more complicated, because some people did not like this type of behavior, so they created a salmonella attack. So it's a smart contract that is trying to bait people who are sandwiching. So I'm not going to go into it, but there's a link in the slides if you want to read the more technical description of this attack. You also have time bandit attacks, where the idea is that you are not just reordering transactions, but you're reordering the blocks. So you can withhold blocks or wait before you release your own blocks as a miner, because you know that based on the transactions that you see, you can get more revenue. So again, all of these are kind of like affecting the consensus in one way or another, and it's not great for the network. There's other types of attacks that benefit from the front running that we mentioned before. So when there's like an NFT sale, basically what you can do is that you can front run the transactions to make sure that you can buy the token at a floor price or faster than anybody else, and then collect all the NFTs, which may or may not be fair. And so again, because of all the opportunities that are publicly displayed, people are definitely trying to make this happen. One of the examples that was identified was someone that tried to buy a crypto punk at floor price, and they paid a lot of money, $7 million at the time. So a lot of very interesting things that can happen around MEV and MEV extraction and the attacks. So obviously this was problematic and it had been going on for a while. So researchers started looking at solutions of what can be done. And so I'm going to go over some of the solutions and explain a little bit of what they're doing. So basically MEV Geth is the idea that we have these price gas auctions and we're going to extract them off chain, just so that, as you saw in the graph before, you're not overpaying and sending the transactions over and over again, but rather you send it to a relay, to another party that you're gonna have to have some trust that will include your transactions. And that way there's not all this leakage of information and also leakage of funds for the transactions. And then the relayers are just gonna put together either the bundle, so like all the different transactions that you wanna make, or just regular transactions from other users that don't want to be front run or back run or sandwich. Put them together, create a bundle, and send it to the miner. And then the miner will just select whatever bundle is most beneficial to include in the block. So this is initially something that the Flashbots researchers developed to try and take away this price gas auction from the network, because it was also causing a lot of network bloating, too many transactions that were just repeated transactions, and overall just creating chaos in the network. And so what they did was that with this MEV get, you move it out of the network and you're only having your transactions included in these bundles that they send, but you're not doing this race or this price gas auction on chain. But again, this is something that becomes problematic because it becomes one single point of failure. Now you're depending on this third party to trust them that they're not also gonna front run you or do anything to the transactions that you're doing. So there's a component of trust. So far, there's nothing to indicate that they haven't been trustworthy. But again, because we're in a decentralized system, you probably don't want to rely on them for this long term. Ooh. The slides are not moving. Sorry, guys. I'm gonna stop sharing and reshare, but I don't know what happened.
How strange.
Let me close down all of my other tabs that might be causing some lag, but it's got a pop up that it is frozen. Let's see.
I've also got your slides up as well. So if you like, I could share and you could see next slide if you like.
Yeah, let's do that because it's not, unfortunately. Okay.
Can you
Okay.
see?
Thanks, Peter. Yeah, so basically, as I was saying, the flashbots are kind of the ones that came out with this solution to MEV to try and mitigate some of the problems that I mentioned before. So they evaluate, like I mentioned before, the bundles, and you have this seal bid auction rather than the price gas auction that was happening before. And so then the bundles get sent to a miner, and the miner will compare which one has the most revenue. So that's kind of why it's saying that it's more democratic, because the miners are able to select based on whoever creates the highest revenue bundles. Next slide. And so this is just a screen capture of the MEV rewards that have been recorded by the flashbots. However, this transaction specifically is trying to highlight the fact that from the gross profit, all of it is going to the miner. So ideally, if you're a searcher and you're looking for these opportunities of arbitrage, liquidation, or like whatever smart contract vulnerability that you found and you want to get that, ideally you want to get some revenue. But even if it's a sealed priced auction, what we find is that it ends up being sort of this race to the bottom where everybody's competing for the MEV, and then they're trying to pay the most to the miner, and in the end the miner is the one that benefits the most, and everybody else doesn't necessarily make profit. But there are some very interesting opportunities as well. Next slide. And I believe this is another type of example just for liquidation. So here you can see that the first transaction, the gross profit is $3 million, and then the miner is only getting $10,000. So for like the person or bot or whomever created that bundle, it is very profitable. You can also see the amount of gas used, and it's just to like give an idea of like how much revenue you can capture.
Can I fire a question in?
Yeah.
So do you have an idea of how much liquidity was needed to be used to make $3 million? Like did that MEV bot have like $1 billion to play with, or how much money do you need to have to make that much money?
So I think that you don't need to have that much money, especially because we have these flash loans, right? So like if you can create a loan in an atomic transaction, then basically you can profit from these concepts that we have in decentralized finance, where you are borrowing, but you're supposed to return it immediately after with some percentage. And as long as you do it all within the same transaction, you're able to extract this profit and pay off whatever you borrowed with the interest that they charge. And that's just because of flash loans existing.
Oh, yeah, that makes sense. That makes sense. All right. So you don't necessarily have to be a billionaire to make $3 million. Yeah.
No, not at all. You just need to be very smart and knowledgeable about how you're going about these opportunities, because again, they get broadcasted. And you also have to trust that if you're using a relayer, that the relayer is not going to be like, oh, this is nice, I'm going to do it myself. And it's always the case that even if you're like very careful with it and you're trying to send the transactions, like there's like what they call like snipers. There's like always like some sort of bot or some sort of some software that is kind of like tracking for these things, because it gets really crazy.
Yeah, and you can see, for instance, that one at the bottom there, the gross profit was 1.2 million, but then they had to pay out $706,000 for fees. So that's a lot of money, you know.
Yeah,
Wow.
that's probably the cases where they're like trying to make sure that they get some of the reward, and they know, like also like the gas, it's related to the gas use, right? So maybe not the most optimal contract. Like I've also seen researchers that work on the searching part, and they even try to optimize for gas costs. So lots of parts to consider.
So what happens if, like me being like this person who's got like, I don't know, $20 or so to you know, anyway, not millions of dollars. If I'm trying to put a transaction into a block where someone's paying a gas fee that ends up meaning $700,000, what effect is that going to have on me trying to put a normal transaction in?
So it does, I think it does increase the price, but I think that there's some other things that come into play because of 1559, because that's supposed to like keep the gas price more or less stable. And also there's this concept of tipping the miner. So some of the amount you see here is the gas, but also like how much you want to tip the miner for including it. So it really depends on, I guess, on these things and on how many transactions are related to MEV at the time, right? Because when these are not necessarily found, the network should still be including transactions from someone that only has like their $20 in ETH. And I've seen like points in time, because it's also exploiting like smart contracts and finding different opportunities. It's not something that is always happening. So it's not kind of like affecting the network constantly, but there's definitely points in time that, you know, you can see. Because see, like even this is not even the same days, like January 21st, like no, well, actually no, never mind. This is like the
Yeah, well, the January 21, 2022 is the only one from this year, but it's still, yeah, it's incredible. $700,000 in gas fees. That's a, I mean, that's a big tip.
Yeah, it's a lot. But these are the top ones of all time, now that I remember, because they have the latest and the top ones of all time. So
with that one that paid that 700 fee from that graph that you showed previously, that could be a result of an auction, right? People trying to outbid each other to get their transaction included, like someone's duplicated the person who found it.
Yeah, that could be exactly it.
And so they bidding up, but you said that they would obviously bid up to $1,283,852 so they can make $1 profit, right?
Well, actually, because of the way these bots are made, I've seen transactions where they end up paying more than the gross profit. So they end up losing money, which is the also crazy thing.
Yeah. But you said they keep making, so the one that gets included in the block may not be the end of their auction. They may keep bidding, but the miners just said, no, I'm already going to publish because I'm going to. So it might have gone up more than 700,000. Just that bid didn't get included.
That too. There's like I said, it can become a race to the bottom or even to the losses, depending on the opportunity and how you're broadcasting it.
That's so good.
But it's very crazy in terms of amounts and how much profit can be made. It's very crazy.
A really interesting bit of analysis would be to see after 15, I mean, well, it's part of it's 1559, but part of it, I guess, is as time has progressed and like say we're up to 2022 rather than say 2019, and hence the number of people doing it and the tech involved has progressed, because you can imagine that, you know, someone's going to have some open source MEV tool and everyone will then copy that. And, you know, actually that's a question. Are the MEV tools generally closed source because people are trying to guard their secrets on how they do it, or is someone got an open source repo that everyone can just clone?
So there's open source repos, but unfortunately, I think that it's for like very specific cases. Like there's this obscure contract that is implementing a specific type of protocol and someone was trying to capture it and then they released it after. So what they released is only specific to that smart contract and protocol. So it's interesting in the sense that you get to understand the logic of someone trying to capture these rewards, but it's not something that is applicable to all the other contracts. Because as you said, like for arbitrage opportunities, for anything that could be found, I guess, like an analog in finance, people are very cautious with how they're sharing their strategies, because obviously they don't want to give the advantage away.
Makes sense. Thank you.
Yeah. So next slide. So in the context of Ethereum 2, so from moving away from the proof of work consensus to the proof of stake, there's other considerations that need to be taken, which we'll see a little bit more about. So one of the proposals to try and prevent MEV in proof of stake is to have this PBS architecture. So the PBS architecture is basically stands for proposer builder separation. So you're trying to separate the transactions and the bundles from this relayer, but also from the builder. So the builder is just supposed to create a block with the transactions that you send, and then they send the header of the block to the validator, and the validator needs to sign the block and return it before they can see all of the transactions. So in this sense, the validator is kind of like the miner, but they don't have access to the full block of transactions, so that they are not gonna take the transactions or MEV opportunities away from the users and searchers. And so in this way, there's some protection and privacy built into the system, but it's not like a solution for everything, but it's an attempt to try and protect these opportunities and transactions. So next slide. So basically this is just explaining how we're separating the roles, and it's kind of like preventing this MEV stealing. But you know, it's like a new protocol, and there's always ways that people find to continue exploiting for MEV extraction. So it's not a catch-all, and it's still being researched as a component of proof of stake at large. So next slide. And then there's MEV Boost, which is kind of similar. So this is a proposal from the Flashbots, so the guys that initially created the app auctions off-chain. They also have their own architecture. It's similar to the one that you guys just saw, but with just some modifications. So if we go to the next slide, you'll see what it looks like. So you still have like your users and your senders sharing their transactions or bundles to the builder. But the builder will send all the information to a relayer, that will put the payload of the block in an escrow, and the validator needs to be checking for headers of new blocks. And then once they have signed it, they get access to the full transactions. So again, they're separating the roles so that there's less opportunities for any one participant stealing the MEV. And we'll see again, how does this fare in the proof of stake? Because as of now, it's not something that's being currently implemented. MEV protection has only been implemented, I believe, in one of the clients. So this is something that's still being looked at and added slowly. Next slide. And so just to get like a more comprehensive view of the things that you can do with the different types of designs and architecture, MEV get only helps with the block space auction. So this is the first solution that we saw, but it doesn't allow users to send full block bids. There's no solo staker participation. So in the context of Eth2, there's an interest to encourage not just big pools of stakers, but also like allow solo, like smaller stakers to participate. Like I mentioned, only one client has implemented MEV get, and the idea is that to encourage people using different clients for the resiliency of the network, you also want to ensure that the clients are implementing these MEV solutions as well. And it doesn't provide privacy or trustlessness. In the case of MEV Boost, it does provide what we've mentioned up to privacy, because it's still not fully private or trustless. You still need to trust some of the components. So you still need to trust the relayers in that solution, versus the proposal builder separation, where it's more, there's more privacy and a trustlessness component. So next slide.
So no one has implemented MEV Boost or PBS?
I believe that MEV Boost is being implemented. If I'm not wrong, it is being implemented in our client. I think they finished it, but most people are like in the process. Most clients are in the process of adding it.
Okay, and for those people who are saying thinking our client, so Vanessa works at Consensus and our client's Teku. Yeah.
Okay, so just like to continue on this, because we're looking at it from the Eth2 perspective, there's also long-term considerations that need to be discussed and talked about. So next slide. So part of the layer 2 is not just obviously changing from the consensus algorithm, but it's also looking at layer 2 solutions. And what we call layer 2 solutions includes rollups. So the idea is that rollups allow for faster transaction processing speeds, but it's dependent on operators or certain participants in the network that will receive all the transactions and validate them. And the situation here is a little bit different, because rollups don't expose transactions to the rest of the participants. When a user wants to send a transaction in the rollup, it'll directly interact with an operator. So in this sense, you are not exposed to front running because other users are not seeing the transactions you're sending, but it still leaves the operator as the main source of vulnerabilities, because they are able to see your transactions and they can determine whether or not there's MEV that they could collect if they decide not to include your transaction, or if they decide to do something before your transaction or after. So that is definitely a point of centralization in this sense. And it's a concern because we're not able to measure or determine specifically as of now if an operator is behaving this way. How can you determine that on a broader scale? Because as a user, maybe you'll think something happened or you might not notice. So it's still something that needs to be researched and quantified. Next slide. Similarly, across the main MEV, just like in decentralized exchanges, there's opportunities to make profit because of the price differences. It also applies to a multi-chain world where you can trade between the Polygon chain that is selling some USDT at a different price that the Ethereum chain is selling it. And then you can find a path to extract some arbitrage opportunities from it. And so this is a area of concern because there's even more things to consider when it comes to the differences between the protocols, how can they extract it, and essentially like how can you prevent from attacks in these scenarios. So there's a very interesting paper that talks about this actually that came out, I think, last year. And next slide. And then just to go back again in the context of the rollups, the operators are going to be like the miners in Eth1. And so this gives them an opportunity to maybe engage in activities that would be consider attacks or extracting value from users or searchers, which wouldn't be good or something that you could trust on. But there is a thought that maybe through encryption schemes, namely zero knowledge, you could alleviate some of these dangers because you could potentially keep your transactions private. But this is a subject of research, and there's still a lot of research to be done in this context. So it's just one of the possible solutions, but it's not something that's currently designed yet fully. Next slide.
Could I ask a question before we flip? I know I'm asking lots of questions during the talk, which is probably very distracting, but
no, it's fine.
Yeah. For a ZK rollup, aren't the transactions private between users? So one user's transaction is private relative to the other user. But if I'm the operator of the rollup, I get to see the transactions as they come in, so I know how to update the state. And if the operator is the one doing the MEV and like inserting the transaction in ahead of your one, then a ZK rollup wouldn't help. Is that right, or am I getting it wrong?
So that's one of the types of rollups that you can do. But then ideally through zero knowledge, you would be able to create a scheme where the operator doesn't know all the components of your transaction as well. So like something that's fully anonymous, because what you're describing, I think it's what currently has been presented as the zero knowledge rollup. So in that case, yes, the operator would be able to see the contents of the transactions while everybody else, it's still private. But there is a thought of having a scheme where it's all private, including to the operator.
Okay, that makes sense. Yeah, cool, thanks.
So next slide. And so finally, just some of the concerns to highlight in terms of MEV. So we talk about the network bloating because of all the bidding. So that's kind of like taking resources from all the other users that want to participate in the network and then get lost in this bloating. There's also the MEV taxes by people engaging in sandwiching attacks, because it essentially artificially inflates prices for people that are just trying to buy or sell some tokens because someone else saw that and then tried to make an opportunity out of it. And especially the time bandit attacks, which again, they play into destabilizing the consensus because they're playing on the ordering of the chain, and that could cause for forks or things that are not good. Next slide. And people are very vocal about it. There's definitely concerns that MEV is not just like, oh, this great opportunity to extract money, but also it's creating centralization points within the blockchain. And it's something that should be built against, trying to prevent. So there's two schools of thought in this. One is MEV is great. It creates revenue. It stabilizes because miners are incentivized to include transactions. And then there's the other one that it's like, no, we should create schemes that prevent this from happening and these attacks because it's destabilizing. So next slide.
I have a question here. So also going back to a couple of slides before, when in that scheme showing how Ethereum 2 plus rollups, I mean, we don't know if it will be one one dominant rollup or multiple rollups, which might flourish. But doesn't that imply if you only have one rollup, wouldn't that be centralized? Is there any?
Yeah, that is a concern as well, because the idea is that like there will be multiple rollups, but eventually there will be one rollup to kind of like rule them all because it offers the lowest transaction fees and the highest speed. And so like all the benefits from engaging with that specific rollup would make users want to go to that one specific. And it does become a point of centralization. That is the thought, or at least right now.
Yeah. And well, probably it's then not really, I mean, probably it's tangential only here, but do you know if there is anything about decentralized rollups?
Decentralized rollups.
Does that even make sense?
I'm not sure.
Yeah, okay, I'll something to Google. Thank you.
Something to think about, yeah. Fuel is a decentralized rollup. Okay, I will look that up.
Yeah, it also sounds like we've got a good argument for why there should be many rollups created so that we have rollup diversity. I'll remember to mention that to someone.
Yeah, keep it competitive, and hopefully there's going to be many. Okay, that makes sense. Yeah, I think that zero knowledge rollups are the ones that are gonna dominate, and they're probably the ones that are able to do something like a decentralized rollup. But zero knowledge is just at such early stages, I would say, of research that nothing that is production ready yet. And yeah, and then the last point of concerns, going back to these transitions from Ethereum 1 to Ethereum 2, or like proof of work to proof of stake, is basically the changes in the protocol itself and how they will affect MEV extraction. Because in the current times where we're doing proof of work, you're also playing on some probabilistic inclusion, right? So you know that with some variation, every 12 seconds, a new block gets created and transactions get added. But in Eth2, it's a bit more complex, and you have these allocated times for when you can propose your transactions for the slots. And so you have 6.4 minutes between the time you know that a block is gonna get created in Eth2. So all that time and that fixed ordering probably will create opportunities for people to work together, perhaps. So like validator pools could use the resources and know that in certain fixed block times, they will be the ones adding transactions, creating bundles or blocks. And so searchers could, I don't know, like pollute or not with them. So there's definitely more sophisticated MEV to come in that sense. And so it's something that needs to be kept in mind when designing in these changes of protocol. Next slide. And I think that's it for me, actually. So
that was a really interesting talk, and yeah, that was really, really good. Lots of questions, yeah. So are there any other, before we talk about future events and stuff, are there other questions that for Vanessa?
Look, I find this a very interesting topic. Do the like those relays and that you're talking about, are they charging a fee or anything like that? Or
Who is charging a fee?
the relays, or the builders
I
in some
get
of the civil
rewarded.
areas,
They are supposed to get rewarded, but not the bulk of it. Most of it goes to the miners or the validators at this point.
Yeah, I think some of the MEV, like say for instance, arbitrage, can possibly be seen as a market inefficiency, right? Because you haven't got the same price in two markets. So it makes sense to like this is actually trying to find the true market value. And I mean, miners obviously get rewarded for running the network, and if you know, like gas price go up and down and so on, I think it makes sense for a lot of it to ultimately go to them because they're kind of running the network anyway. And if it was a fully efficient market and there was no arbitrage, everyone had exactly the same price, then people would still be willing to pay X for transactions, and that would X would go to processors or validators. So I think that makes I think it's okay, but I mean things like sandwich attacks seem like bad. Is it possible to make things fully anonymous? Because all you probably need is that, like, here's my transactions, its hash is X, and I'm willing to pay, it's Y bytes long, and I'm willing to pay Z for it. When you've agreed to include it in a block and given me the signature of the block, I'll tell you what the transaction contents is.
Yeah, so I think that's the idea behind the PBS, because you're sending just the block header, so like a hash of your block with all the transactions. So that kind of like, that's kind of why we say that it gives some privacy, because you're not sharing the contents of the transactions until it's been signed. And then, but
So
yeah.
it's very similar to like stateless Ethereum and stuff like that, where they don't need to know the state, they just need to know the headers.
Yeah.
Someone somewhere needs to keep the state. If you like that transaction, you want to keep the state, but you may pay someone else to keep the state for you. But not everyone needs to know the state.
Yeah, exactly.
But then what happens if I submit a transaction and say, hey, can you include this transaction? You say, sure. And then I give it to you and it uses like, I don't know, 100 million gas because it's got a for loop or something crazy. Anyway, as something which uses.
Yeah, I don't know. You have to validate that how much of gas is going to use and how much of this and that and so on. And some of that might not be knowable in advance, right? So, yeah. And I guess what happens if you say I'm not going to give you the transaction now? So there's a missing transaction, and then later on I say, oh, here it is when it's advantageous. So you might need some sort of two-phase commit of I've agreed to include it. Tell me what it is. Here I can prove that I've told you. Okay, now we include it. And then some penalty if you don't, if anyone backs out. Aha, it's got a for loop or whatever. Well,
yeah. Vanessa, there are a few questions. So Mark Staples put one in, which I think, yeah, anyway, there's
so yeah, I mean, it's a design choice, because the argument seems to be that if we try to enforce something to prevent it, it's going to just move the problem somewhere else. So rather than trying to fully stop it, they're just trying to minimize it. And I think one of the answers, so what Horacio said here, like you can't fix it, so you're just trying to make it a nuisance or like democratize it or avoid it being a bigger problem than it already is, because otherwise it's just going to show up in another part of the protocol. Like there's talks on what is like fair ordering, right? Because like it seems like you can't say, okay, we're just going to pick the first transaction that's received and like order it on that based on that, because then like how is it fair? And because of latency, like nodes that are placed closer together will be at an advantage. So is it really fair? There's a lot of very interesting discussions and talks about different ways of addressing MEV. And I think ultimately it's something that maybe through encryption schemes can be mitigated more long term. But as of now, it's something that we're dealing with and trying to find ways that it doesn't disturb the rest of the network.
Yeah, and so my understanding, based on a conversation yesterday, is that that the merge is likely to happen just this side or in mid to late September, and so in time for DevCon in October, which is very exciting. But I guess that means that, say, MEV Boost, assuming it's being implemented by everyone, it's the thing that is going to be used. But I guess we would probably know whether it's going to go live or not in the first version, like when the merge happens now, simply because surely they don't want to change anything as complicated as that. So maybe is that, yeah. I wonder if that's going to actually go live at the time of merge, or whether it'll be something that'll go live in 6 months.
Yeah, we'll see. We'll see when it happens.
Yeah. Okay, so there are all sorts of questions going through, or I think it looks like more like discussion. So maybe we'll leave these people to. So whilst the discussion's happening in chat, I'll present the forthcoming talks.
There was a question there about good MEV.
Good MEV. Good MEV. Is there such a thing as good MEV?
Do they mean back running, or there are other user neutral?
Also, back running could be considered like good MEV, because you're not affecting the person that just sent the transaction. Also, just like arbitrage, just regular arbitrage should be like good MEV. The problem is that once you send it, you're at the risk that someone attacks you because everybody else wants to do the same strategy. But then the other attacks are definitely not good.
Like sandwiching, and then even back running would, in theory, affect the price for people later on, potentially. Whereas arbitrage is just a market correction, because two markets have different prices, and the efficiency, you're just correcting it.
The type of MEV that I don't like is when, so a lot of these protocols have the idea of a fisherman or something like that, an observer who observes some bad behavior and then is going to get rewarded for pointing out that something bad's happened. So you put that in to claim your prize, then of course you get MEV'd, and so someone else gets your prize. So hence you're not incentivized to report bad behavior because someone will steal your prize.
Yeah. I've seen some instances of that happening.
So the problem there is that not the MEV itself, like, and even arbitrage opportunity, the same thing. You see an arbitrage correcting the market, but then the problem comes that everyone else sees you're claiming the arbitrage, and there's this bidding war that happens on it, and that chokes up the network and so on. So it's not the first MEV itself, it's the fact that the protocol is so open so that there's some level of them, anyone can see it. But then that means that whoever's the largest probably has some advantage in trying to actually obtain that MEV compared to everyone else.
Another question, Vanessa, how did you find those transactions that you showed? Do you have any, any dashboard somewhere? Did you find them manually, or?
I can't remember for those transactions because I know I took them a while back, but I can take a look and I can send them to you if you're interested. I can share that.
I'm interested in the general way to find them. Because for example, some time ago, sorry.
I can't remember if it's on the MEV Explore page itself that the flashbots have, or if it's other pages, because there's other pages that are like tracking this information, but it's not always available.
Okay. Okay. I didn't know that there is specific stuff for this. Okay. Thank you.
Yeah, and I think so. Ermias has put a link in, and there's a more discussion here. I'm going to share the forthcoming talks, if I can, yep, that's the one.
Yeah, I think MEV is very contentious because of that, because there's people that feel very strongly against this kind of like exploitation of opportunities, and
Yeah,
it's not necessarily the best approach to let it happen but minimize it, but it's the best that can be done for now, I suppose. So that's that.
yeah. So be it. Yeah. Okay. In about 2 weeks' time, Ermias was going to do a talk on atomicity of cross-chain transactions, and he's decided that it'd be better to do a broader talk on the actual security of cross-chain. And so we've bumped that down into August. And instead, I'm going to do a talk on cryptography and security domain separation, and why it's important and what it means to improve your application security, so that you don't, in times of attack, leak, say, your cryptographic keys by a well-funded and organized attacker. So that's going to be in 2 weeks' time. Yeah, so I've already actually done that talk or something similar about 3 years ago, 4 years ago. So I've got most of the content, so that should be nice and easy. 2 weeks after that, I'm going to give another talk, actually, which is the one that's been planned for longer, on smart contract security. And after that, Ermias will give his talk. And then in early September, we've got Paul Ashley, who's going to come along. So he's someone who I actually did undergrad with, and he runs a decentralized identity and anonymous identity company. And so he's going to talk about DIDs and give us a really good backgrounder in that. And yeah, so that's the forthcoming talks, and with more on the way. I can see David Pierce there. David's gone off mute, so he's obviously he's busting to give us a talk. He's a recent hire at Consensus, and he's got lots of good ideas on talks that he's going to give. And there are the socials.
I'd be happy to give a talk at some point, Peter.
Sounds good. Sounds good. All right. Are there any final questions for Vanessa? No, lots of virtual clapping. So thank you very much, Vanessa. It was great to finally have you on after, yeah, and it was an awesome talk. So thank you very much.
Thank you, guys, and thanks for all the questions. It's always fun when people are asking questions. So
yeah. All right. Talk to you later. Bye-bye.
bye.
Thank you so much.
Thank you.
Bye-bye.